Hello everyone, welcome to your next data structure lecture. I'm RVD and let us go ahead with the next topic in this series. So in this video, we will be looking at array implementation of circular queue. See, in the previous video, we have discussed in detail the circular queue conditions. And so if you have not seen that video, you can very well see that video before coming to the array implementation. You can see the link of the video in the description. Fine, so let us go ahead with the array implementation of circular queue. So let us start with the live implementation using IDE. Fine. So I hope you people are already learned simple queue. Again, if you have not done that, you can very well first look at the implementation of simple queue. Again, the video is there in my data structure series only. I have already posted the link in the description for that as well, so that you will be able to understand this particular implementation easily, because it will go obviously with the same style. So we are starting with the structure. So let's say type def struct. Okay, I will need an array, let's say q. I will need f and r for sure as usual, and as we have discussed earlier, we have to maintain count, okay, which will be an extra mechanism. Okay, let us have the name of the structure as q. So first we will start with the implementation of insert. Insert will take q star t and ELE. Now, because we have maintained count, the condition of overflow becomes very easy. So I would simply say if count is equal to max, then that can be considered as queue overflow, because obviously queue is full and we are trying to insert an element into the queue. So that can be considered as queue overflow. We cannot do insert, so we can simply return. Fine. Now, if you are not getting that condition, that means my queue is not full, I'm surely going to insert the element. Now, as I said, we only have to maintain the count so that we can use it. So as we have decided to insert, the first very important thing I'll be doing is count should be incremented. And remember one thing, count will always be incremented with the simple increment. We have discussed that we require the circular behavior, so we have a special increment that is using modulus, but that is not for count. Count is not supposed to revolve circularly. So that's the reason the count has to be simply incremented. Fine. Okay. Next is, now think about the insert. Where do we do insert? Front or rear? Obviously at the rear end. So we have to increment R, and now R needs circular behavior. So see how I'm incrementing R. R equal to R plus 1 won't be enough. So it has to be R equal to R plus 1 in bracket mod max. We've already discussed what is the effect of this. That is, it gives you circular behavior. If my R is at the corner, okay, this particular style will then make my R to point to the beginning. That is, if it is at max minus 1, it will be pointing to 0, and we get the illusion of the circularness. Okay. Now I can very easily insert the element as I generally do. So T arrow Q of T arrow R equal to ELE. Fine, so that's how I'll be able to implement insert. So you can see there are major two changes. The condition for overflow is count equal to max, okay, and we are maintaining the count, and while incrementing R, we are using the modulus. Okay, let's go for empty. So is empty. Again, is empty is also being made very simple because of count. So if the value of count is 0, I can simply say my queue is empty. So I can return 1, else I can return 0. Fine. Let's move ahead with delete then. Again, the same problem with delete. So we have to say delete 1. Delete is considered here as a keyword. Okay, I will need int z also. So you can see a lot of things are quite similar to simple queue. First, I will be checking is empty. So is empty t. If it is empty, queue is empty and we are trying to delete. That is being considered as queue underflow. and the return type is int, which will force us to return some value, which generally we return -1. And all of you know how do we handle this in main. Okay, if it is not empty, then I'm very sure that I'm going to delete. So again, I have to maintain the count. So t arrow count minus minus, and then we will do the formality of deletion. Deletion is done from the front. So z equal to q of f. So t arrow q of t arrow f. After that, we increment f generally, but here f also needs circular behavior. So f also should be incremented using the modulus option. Okay, so that will also make my f to revolve circularly. And then the deleted element is there in your z, so that has to be returned. Fine. As usual, we can very well go for q front with the help of delete. Q front actually will be exactly similar to your simple queue, because q front has nothing to do with whether the queue is simple or circular. It simply has to return the what you can say, frontmost element, copy of the frontmost element. But let's see quickly. So if it is empty, instead of saying underflow, we simply say q empty. Okay, return -1. Otherwise, t arrow count minus minus won't happen. Your f will not get incremented. I would simply return t arrow q of t arrow f. And that's the reason, if you remember, I said it is exactly same as simple q. Fine. Let's go for display now. Okay, the initial part is going to be same. So let me take the advantage of that. Only will need for loop variable. Okay, so here also we check if it is empty, we'll display empty. Otherwise, we are going to display it. Now understand the difference between the normal display that we had used in simple queue and this one. In simple queue, we simply started displaying from F and we've gone up to R. Now that may not be the suitable solution here, because if you have understood by now the concept of circular queue, it might happen that my R, when it goes up to the corner, and if at all there are some spaces at the beginning, my R can circularly come back at the beginning and can add more elements. So in that situation, my F will be ahead and my R would be behind F. So a simple solution of starting from F and going up to R in the for loop is not going to work, or may not work rather, always in circular queue. So we are going to devise a different mechanism. Okay, so let us have I, okay, starting from F. Because remember, one thing is still same, that I have to display the elements from F to R. So see how I'm making that happen. I'm simply taking while one, which is our near dear friend. It helps us many times. While one obviously will repeatedly go for a particular set of statements in infinite manner. So when we don't want, we can break. Fine. So while one in bracket, okay. Now I already had assigned I to F. So very safely I can do the job of printing. So I'll be printing the current element, which is at I. Now after I've done that, the condition for stopping is if my I has reached up to R. Can that happen at the beginning also? Yes, it might happen if there is only one single element, but still it has already got printed. So if my I is now matching with R, I will simply break. Okay, and if not, we'll see. So if my I is equal to R, then actually the work of displaying the elements got over. So I have to break. If not, then I want my I also to get incremented. But try to think, you want circular behavior for I or you don't? Obviously we want, because if at all I've started somewhere at the corner, and after displaying all the elements on that side, if there are elements on the other side, because my I is still not equal to R, then my I also should circularly go to the beginning. And that's the reason the increment that we do on I should also be using modulus. So I would be doing I equal to I plus 1 mod max. Okay, so that will do the job of displaying the elements. Again, as usual, we have a habit of putting slash in so that we don't stay on the same line. Okay, and that can be completed. So that's how I can implement the various functions of your circular queue with the circular queue conditions. Now, as far as the main is concerned, okay, you can clearly see all the functions that I've implemented here are same, or at least the names are same as simple queue. So I've already kept the simple queue main function ready for all of you. Fine, I've already suggested at the beginning that those who have not seen simple queue implementation can see that, or rather even the array implementation of stack, I've written the main in detail. So that video also would be helpful for you to understand. But currently you can see all the functions that were being used in your simple queue implementation are as it is. But still roughly, I've created the variable. I've assigned, yeah, I need one extra assignment, okay, which obviously otherwise it would have created really a danger execution for us. That x.count should also be initialized to 0. Maybe one more change I can do that will be better. X.r, instead of starting with -1, I can start from max -1, because logically that's obviously appropriate, because who comes before 0 is max -1. We are in a circular manner. Okay, so otherwise I guess rest of the things would be same. Let's check. Okay, fine, we got a success. So let us see the execution and we'll try to see how circular queue discards the problem with simple queue. Okay, the size I guess we've kept is 5. Okay, so first delete will obviously show underflow, which is perfect. I'm inserting 10, 20, 30, 40. Okay, let me go up to this. Now see, if at all I say queue front, it will give me 10. Number of times you say queue front, it's going to give you 10. Okay. Now let me add one more element, let's say 50. Now you can see the queue is full. So if I try to add more elements, let's say 60. Okay, it's going to show overflow. Now some of them they say, sir, how we've got overflow? It's a circular queue. See, we don't want to create magic. As all these slots of the queue are occupied, it is bound to declare overflow. Now what was the problem with simple queue? I would highlight first that if at all I delete now one element, okay, let's say, let me delete. So obviously it's going to delete the frontmost, that is 10. Now if it would have been simple queue, if I still try to insert, it will declare overflow. Which was the problem? That there is a slot pending in the simple queue, but still it is not utilizing that, which will not happen for circular queue. So let us prove that by testing. So now you can see one slot got free. So it should allow me to add 60, and physically 60 is getting added at the beginning, but as a user it shouldn't be visible to me. For me it should be my queue starting from 20 going up to 60. So maybe these things you would be able to check with the output. So now let me try inserting 60. See, it allows me to insert and see how 60 is being displayed. Maybe we know the inner part, so we know 60 is actually stored at the beginning. Maybe if at all you're not getting it clearly, in the next video, I will rather devote a complete video for working of circular queue, which will make you clear about how exactly the things are going to work. But it is now clear that if the array has empty slot, it will not declare the overflow. Fine. Let me just show you the deletion now. So this will delete 20, then 30, 40, 50, 60, queue is empty, underflow. Fine, so the problem with simple queue is being rectified by circular queue. Okay, so that was the implementation of circular queue. Okay, it was a very, very important concept, and I hope you people are finding it easy now. So you can try implementing it yourself so that you will be able to get more hold and more comfort on this particular topic. As I already said, in the coming video, I'll be explaining the working of circular queue in detail, which will further help you in making yourself comfortable with circular queue. Okay, so for the time being, that's it from this video. Thank you and happy learning.